Namaskar my dear students. In our last videos you were studied about the design for fluctuating load for finite life problem for reverse load. Now today we are going to learn about the infinite life problem for fluctuating load. Let us understand with one example. A cantilever beam made of cold drawn steel 40C8 SUT 600 Newton per mm square and end point stress 380 Newton per mm square is shown in figure. The force P acting at the free end varies from minus 50 Newton to plus 150 Newton. The expected reliability is 90% and the factor of safety is 2. The notch sensitivity factor at the fillet is 0.9. Determine the diameter D of the beam at the fillet cross section. Ka is equal to 0.77 and Kt is the theoretical stress concentration factor is 1.44. Now you can see here this bar is subjected to the load which vary from minus 50 Newton to plus 150 Newton. Okay. Now we have to find the diameter D at this fillet radius. Okay. And you can see the distance between this load to this point is 100 and the total distance or the total length of this bar is 150 millimeter. Now given data P, which is minus 50 Newton to plus 150 Newton, ultimate stress 600 Newton per mm square, end point stress 380 Newton per mm square, reliability 90%, factor of safety is 2 and notch sensitivity factor Q is 0.9, surface finish factor Ka is 0.77, stress concentration factor 1.44. Now solution. The first step to find out the endurance limit stress for the cantilever beam. So first of all we have to find the endurance limit for standard specimen. So SE dash is equal to 0.5 SUT. So value of SUT is 600. So it is 300 Newton per mm square. Now assume the diameter is in between 7.5 to 50 millimeter. So for that the KB size factor is 0.85. For reliability 90%, reliability factor Kc is 0.897. Now fatigue stress concentration factor Kf is equal to 1 plus Q Kt minus 1. So put the value of Q is equal to 0.9 and Kt is 1.44 given. So Kf is equal to 1.396. Now find out the stress concentration factor Kd. Kd is equal to 1 upon Kf. So 1 upon 1.396. So value of Kd is equal to 0.716. Now find out the endurance limit Se of the component. So as per our equation, Se is equal to Ka, Kb, Kc, Kd and Se dash. Now put the value of all these four factors and Se dash in this equation. So you will get the value of Se. So by putting Ka, Kb, Kc, Kd and Se dash, so value of Se you will get 126.11 Newton per mm square. Now second step, construction of modified Goodman diagram at the fillet cross section. So to construct the Goodman diagram, first of all we have to find the maximum bending moment. So you know that the maximum load is 150 and the distance is 100. You can see the distance at the fillet is 100. So the maximum bending moment you can find MB maximum is equal to 150 into 100. So 15,000 Newton into millimeter. Minimum bending moment minimum load is minus 50 into 100, so minus 5000 Newton into millimeter. Now mean bending moment MBM is equal to 1 by 2 MB maximum plus MB minimum. So put the value, so you will find the mean bending moment is equal to 5000 Newton into millimeter. Now bending moment amplitude MBA is equal to 1 by 2 MB maximum minus MB minimum. So by putting the value of MB maximum and MB minimum, you will get the MBA is equal to 10,000 Newton into millimeter. Now value of theta. So tan theta is equal to MBA upon MBM. So tan theta is equal to 2. So therefore theta is equal to tan inverse 2. So value of theta you will get 63.435 degree. Now using all this data, construct the modified Goodman diagram. So you can see in this Goodman diagram, on this axis sigma m and on the y-axis sigma a. Okay, so it will start from the here, that is the end point stress 380, and also here SYT is 380, SUT is 600. Okay, now here endurance limit is 126.11. So the intersection point of this Goodman line and yield line is B. So you can see this OABC is our modified Goodman diagram. Now here you can see the angle theta, value of the angle theta is 63.435 degree. Okay, so here tan theta is equal to sigma A upon sigma M. Now using this modified Goodman diagram, find the permissible stress amplitude. So the coordinates of point X are determined by solving the following equation and the equation of line AB. The equation of line AB is SA upon SE. S is 126.11 and SM upon SUT. So SUT is 600 is equal to 1. And another equation of line OX, this line. So equation of OX is equal to SA upon SM is equal to tan theta. Here this is SA and SM. So SA upon SM is equal to tan theta and tan theta is equal to 2. So by solving this equation A and B, put the value of SA is equal to 2SM in this equation. So you will get SA is equal to 114.12 Newton per mm square and SM is equal to 57.06 Newton per mm square. Now in next step, find the diameter of beam. So we know that sigma A stress is equal to SA upon factor of safety. So here this is 32 MBA upon pi d cube. Sigma A is equal to M by Z. M by Z, M is the bending moment and Z is the section modulus. So 32 MBA upon pi d cube is equal to SA upon factor of safety. Now put the value of SA, factor of safety, and MBA in this equation. Okay, so MBA is 10,000, SA is 114.12 and factor of safety is 2. So our answer D is equal to 12.13 millimeter. Thank you.